Hey everybody, welcome to this morning's hangout. We've got actually a pretty cool little discussion going on this morning. We got Dr. Rana from Reasons to Believe and Bill Ludlow. A lot of you guys remember him from the debate that he had with Ken Hovind. We have some pre-formed questions that we're going to be asking both of them and then kind of open up to the panel. Of course, if you're in the live chat and you want to have a question asked, we might be able to get you in. But let me introduce my two guests here. First is Bill Ludlow. He is quite knowledgeable about evolutionary biology. He's worked for museums. He's been participating a lot in these types of discussions and debates. And if you haven't gone and watched his discussion with Kent Hovind yet, I highly recommend it. He did a brilliant job, masterful presentation, and I have a link to his channel below if you just want to watch the presentation, if you don't want to watch the whole debate. And I've also got Dr. Rana, who is the Vice President of Research and Apologetics at Reasons to Believe. He's the author of several groundbreaking books, including Who Was Adam?, Creating Life in the Lab, The Cell's Design, and Dinosaur Blood and the Age of the Earth. He holds a PhD in chemistry with an emphasis in biochem from Ohio University. And Fuzz actually sent me a copy of his book, Dinosaur Blood and the Age of the Earth, which by the way, I still reference quite frequently to people in conversation. So I very much like to thank him for that and welcome him back to the great debate community. So Fuzz, welcome back.
Yeah, thank you for having me again. It's hopefully it'll be a lot of fun.
Always. I'm not going to lie. You are one of my favorite guests.
Thank you. That's kind.
Really, seriously. We're gonna jump right into it because I know we're probably going to be limited in time. We're going to put a bunch of information in about an hour here, so let's get right into it. I'm going to start off asking you the question first, Fuzz, and then we're going to ask Bill, and you kind of have a compare and contrast of different models, compare the Reasons to Believe model and modern evolutionary synthesis. So, first question: how does Homo sapiens sapiens share common ancestry with all members of Hominidae from Pyrlopithecus catalonicus, which was about 12 to 13 million years ago onwards, fit into your evolutionary model?
Okay, great. You know, and I think a point that probably will come out in the debate or the dialogue that we're going to have is we really are approaching the same set of data from probably two very different worldview perspectives, for lack of a better term. You know, I come at it from a perspective of a Christian worldview where I take the position that God is a creator who brought the universe and life into existence, that God is responsible for the design of living systems and has orchestrated the history of life on Earth according to his purposes. And I would argue that that worldview is rational. I was an agnostic in graduate school, and I became convinced first that there must be a creator that exists because of what I saw to be the insufficiencies of chemical evolution to account for biochemical systems, and then later converted to the Christian faith and am convinced that Christianity is true for a whole host of reasons. And so once I'm in that particular worldview framework, the question then becomes, how do I make sense as a Christian who is an older creationist of things like the fossil record that you're referring to? And, you know, I would argue that the fossil record reflects, again, a real natural history of these hominins and creatures like them, that we can learn quite a bit about their biology and their relationship to other hominins from the fossil record. But I would argue that the fossil record is essentially the product of a creator. So that's how I would look at it from that perspective. And I would point out that there are, in my mind, some pretty nagging issues that anthropologists face when they're trying to interpret the fossil record in favor of an evolutionary framework. While I would agree in a broad sense the fossil record supports an evolutionary paradigm, there are again some nagging issues. One of them, for example, recently came up when a team of researchers reported on the discovery of, I think it was Greco-Pithecus freybergi, this hominin that presumably existed, or a pre-hominin that existed in Greece and Bulgaria, that suggests that the origin of humanity happened in Europe, or at least the lineage that led to humanity began in Europe, not in Africa or Asia, which has long been a standing prediction of the evolutionary paradigm. Or if you look at attempts to identify last common ancestors in that fossil record, for example, we don't have any clue what that last common ancestor would have been like, that presumably gave rise to the lineages that culminate with chimpanzees and with modern humans. We don't know what that common ancestor would have looked like for the transition between the Australopithecines and the Homo genus, nor do we know what that last common ancestor would have been that would have given rise to humans and Neanderthals as separate lineages. So there are issues like this that I think are really, that really justify skepticism, I think, on the part of an old Earth creationist, that while in a broad sense you could interpret the fossil record in favor of evolution, when you get down into the nitty-gritty details and you start making specific predictions, the fossil record just simply doesn't yield results that one would expect if an evolutionary framework was the most robust way to understand the origin of humanity.
Okay. Bill, do you want to go ahead and answer the question and maybe kind of redirect a little bit according to Fuzz's answer there too, if you wish? You're going to have to unmute there, Bill. Mute, Bill. Unmute.
I thought I did.
There you go. There you go. Okay. Go ahead.
All right. Yeah. First of all, like Homo sapiens sapiens, Homo sapiens neanderthalensis aren't really used much anymore in the paleo and in the community. That was kind of a thing that started maybe in the 80s, but now that we have the genomes completed, pretty much it's Homo sapiens, Homo neanderthalensis. I mean, nobody's really dividing those so much anymore. Now that we know that they are two separate but closely related species. But the fossil record is pretty spotty beyond, say, 4 million years. It gets even more spotty after 7 million years, but we're discovering more and more all the time. We've got a pretty good chain going back to about 34 million years. But what we're finding out is it's not a ladder-like progression. It's more of, we had groups of hominids or hominins around at the same time, and you can't say that there's this direct chain of one species to the next. And I think that's the mistake people make if they're looking to see just an unbroken chain of one species to the next. We had populations of different types of apes around at the same time. I don't see the discovery in Greece as any issue at all, because we had populations in Africa at the same time. We know that. So there were populations there. Some would migrate, leave, come back. Other ones migrate out. There's a lot of mixing going on, interbreeding going on, and for the most part, a lot of times the next level up was hybridization between those. So let's see. Again, I don't see any issue at all between the transition from Australopithecus to Homo. We've got a lot of fossils there. We've got, again, different ones. We have Sediba, we have Africanus, we have Afarensis, we have Anamensis. We can kind of see a chain there. Sediba was probably an offshoot, but there's no reason to think that we couldn't have, our ancestors couldn't have interbred with them at the time, early in their evolution. But I think, especially from Homo habilis on, I mean, we have really an unbroken chain, and we do have the common ancestor of Neanderthals. I mean, I think the genetics shows that from what we learned in Spain there with the 430,000-year-old DNA with Homo heidelbergensis, that we do have a common ancestor with Denisovans and Neanderthals and modern humans. So,
okay, Max, if you want to address that particular question to them, so give your question and give who you're asking it to as well.
Right. So in terms of demarcating between one species and the species they transition into, what kind of informs your demarcation? So, for example, I kind of think of it like beards. Like, you could line up one guy who's completely smooth shaven. You could put on the other end a guy with a full bushy beard, but it's pretty hard to tell exactly when facial hair transitions from, just scruff to a beard itself. And it seems that hard when it comes to species transitioning, why do you demarcate it at one particular spot, and what usually informs it?
Are you asking me, or is this Fuzz?
Actually, it's for you, Bill. I'm kind of curious.
Okay, sure. Yeah. Yeah, I mean, it is really hard to differentiate the species. I mean, what we have to look at is we're seeing more derived traits appear in the fossil record. We're seeing things like increased cranial capacity. We're seeing arms getting shorter and legs getting longer. We're seeing a change in bipedalism starting at 7 million years ago. And that is really, I mean, what you have to look at is you're going to have the combination of those primitive traits from the species that go before and the more derived traits for the species that come after. But I mean, it's just anymore, we have so much in the way of human evolution, and we see so much variation a lot of times from different species that are alive at the same time. We can't just draw a line and say, this is a new species. Hardly. Look at Homo erectus. I mean, the variation from Homo erectus, we see them with cranial capacity from 800 cc's up to 1200 cc's throughout the course of their evolution. And we see a lot of changes there between when they started and when they were gone. So.
Well, let's ask Fuzz here. How does the line of demarcation work in the reasons to believe model as far as determining new species?
Well, I mean, the way I would imagine that you would go about doing that would be some kind of cluster analysis where you would have, an ensemble of fossils, and you're looking for, with a multivariate analysis, some combination of features that seems to define a particular group. And so that's how I would imagine you could go about doing it in the most robust way. But, and this is not really meant as a criticism against anthropology at this juncture, but the fossil record is sparse enough that it's very difficult to know really how to group fossils and of course you have the lumper and splitter controversy, or some paleoanthropologists see differences as being significant and will group fossils in distinct species groups based on, again, minor differences or perceived minor differences. Others will kind of combine things together. So it's really not clear how many species existed, but that's more of a function, I believe, of just the sparseness of the fossil record. But in my mind, that actually, I think, I wouldn't say creates problems, but should really be a point of caution on the part of evolutionary biologists, because, for example, when it comes to the mode and the tempo of brain size increase through the fossil record, depending on how you plot the data, you can see either these gradual increases in brain size over time, or you can see essentially discontinuities. And part of the problem is, let's take Homo erectus as an example. Homo erectus was on the planet for, I don't know, close to 1 million years, just ballparking it, and we do have some significant number of Homo erectus remains, but if we don't know how brain size varies at a particular point in time for that group, or how it varies across that population, then how can you make any kind of assessment of changes in brain size when you just have, again, a fairly spotty record? If you don't have that understanding of population variability with respect to brain size as a trait, or again, how it varies across geography, you can't really make assessments of how it's changing across time just by simply plotting things, because you don't have that sense of uncertainty. So you might see what appears to be an increase in brain size, but how do you know that's just simply not a statistical anomaly, not an actual trend, or in reflecting, again, the mode and the tempo of brain size change? So I think this to me, I think demands a lot more caution on the part of evolutionary biologists as they're describing the evolutionary model. Part of my complaint is that many times the way in which human evolution is portrayed, not only to the public, but also even when you're looking in textbooks, it's as if things are extremely rigorously and robustly established, And yet when you start getting into the literature, you start looking at what happens when new hominid fossil finds are made, it seems like those finds throw things into chaos as opposed to bringing clarity. And so to me, I think that's really important to communicate that broadly, just how speculative ideas are when it comes to human origins from an evolutionary perspective. And there should be some communication of just, again, how uncertain I think the picture really is.
RJ, did you want to quickly expand on that just for a minute?
Yeah, the Greco-Pithecus paper, I put a link up to that. The fossil record for chimpanzees is absolutely terrible. In other words, you're dealing with an issue where you have relatively little data, and this is now a new little blip on the data scope, and it doesn't make any of the hominid data for the millions of years afterward that puts us so closely connected to Africans away. And it should be pointed out that anti-evolutionists in general miss most of the data streams, so this is another part of that's being data selected.
And I should point out that I wouldn't categorize Fuzz or Reason to Believe as anti-evolution by any means. Matter of fact, I think they accept most of the evolutionary models, just some of the minor stuff when it comes to human evolution. Is that correct, Fuzz?
Well, you know, we would embrace, obviously, quote-unquote microevolution, speciation. I would allow evolution happening at a genus or even a family level. I'm not quite sure where that line would be, where, again, I would be uncomfortable embracing evolutionary explanations for, again, you know, biodiversity. We would accept microbial evolution. We're skeptical about chemical evolution and the idea that evolution could have a creative potential beyond varying a type or a core design, if you will. So, you know, we're skeptical about aspects of the evolutionary paradigm, but not out and out total skeptics.
Okay. All right, we're going to move on to the next question here. How does the Reasons to Believe model differ from modern evolutionary synthesis? And what testable evidence could falsify the RTB model and the modern evolutionary synthesis model, or make one more useful than the other? And we'll ask Fuzz again first.
Okay. Well, I sort of began that answer responding earlier, but you know, we would basically, again, embrace aspects of the evolutionary paradigm, the idea of microevolution, speciation, in a broad sense, microbial evolution, again, skeptical of chemical evolution for good scientific reasons, and then skeptical too about macroevolution. And, you know, part of the basis for that skepticism is the idea that currently we don't have, from an evolutionary framework, good explanations for what I would consider to be some of the most significant transitions in the history of life on Earth. Not only the origin of life, but even the origin of eukaryotic organisms, as an example. I know that the endosymbiont hypothesis is a leading idea, but when you start pressing into the details of that hypothesis, there's a lot of armchair speculation that's not bolstered by a whole lot of data. And so it's, you know, and you've got this phenomena called the eukaryotic Big Bang, which is highly enigmatic. When we move to the Cambrian explosion, there's not a good explanation for the origin of body plans. There are ideas that are out there, but none of them seem to have robust explanations. In fact, if you read James Valentine and Doug Irwin's book, the textbook, the graduate textbook on the Cambrian explosion, on the basis of their analysis, they're calling for an expansion of evolutionary theory in order to accommodate the origin of body plans. There's no explanation for the origin of consciousness. There's no explanation for the sociocultural Big Bang and the sudden appearance of human exceptionalism. And, you know, there are instances where, again, the paradigm does suffer from failed predictions. And so I think one is justified in expressing some measure of skepticism about this grand claim that the evolutionary paradigm can explain and account for the entirety of the data that's coming from biology. I don't think that's the case whatsoever. And then the way we would look at the fossil record in shared biological features, shared genetic features, which is in many instances what people will cite as the most common evidence and the most compelling evidence for evolution, we would say, again, the fossil record reflects a history of divine orchestration, and that the shared features that we see reflect common design as opposed to common descent. you know, how would you go about falsifying that view? That's a great question. I spent quite a bit of time thinking about it. And, you know, the problem is falsification, and hopefully this isn't viewed as it's trying to evade the question. Falsification is a really great idea in principle when it comes to science, but it's a very difficult idea to execute in a practical sense, because there's always ways in which people can sidestep evidence that goes against their theory. And so, you know, falsification, and that applies, I think, to both frameworks. And I think there's also philosophical pre-commitments that also influence whether or not ideas are, you know, falsifiable. And I think, you know, would be just as guilty as anybody, you know, towards that end. But part of what we're doing at Reasons to Believe is trying to move towards the ideal of falsification by presenting what we call a creation model, where we take what we can find in Scripture where it speaks about God's work as creator, and then we try to recast our understanding of Scripture in the form of scientifically testable statements that we would argue represent our model. So we've got a fairly fleshed out model for the origin of life. We try to present a model for the origin of humanity in the book Who Was Adam? And the book Who Was Adam was actually updated a few years ago. It was a 10-year update. And we went back and we reevaluated our predictions in light of new discoveries that happened since the first edition of Who Was Adam was published. And in that assessment, we identified places where we made predictions that didn't come to fruition, and other places where our predictions bore out. And so it was an attempt on our part to really apply the ideals of the scientific method to this question. But, you know, in that process, even though our model suffered from a few failed predictions, it wasn't, in our view, enough to overturn the model. It just forced us to revise or to accommodate those new discoveries through modifications of the model, which is, in a sense, the nature of how science progresses in any discipline. So, you know, I don't know that I could answer the question exactly how we would come up with that one test that would falsify our model. Would be open to hearing what the panel might think about that. But with our creation model approach, it's at least an attempt to try to put our ideas in harm's way and at least move towards the ideal of the scientific approach to developing an understanding.
Okay, let me ask Bill. Bill, we do the question in case people have forgotten by now, but what testable evidence could falsify modern evolutionary synthesis, and what would you think makes that more useful than the RTB model that Fuzz was just talking about?
Right. Yeah, I can't speak too much for the RTB model because I'm not that familiar. I mean, from what I've seen on the videos, I see challenges to the modern theory of evolution being presented, but I don't see a lot of alternatives there. So, but what I think the biggest thing that would falsify it was, and I stressed this all throughout my debate with Kent Hoban too, was we just don't see us in the fossil record alongside these other extinct species. That would falsify it. I mean, if we found modern humans, and I don't think we disagree on the ages, at least here, you're not dealing with somebody that says it all happened at a flood at once and all your dates are wrong. I think if we agree that we're going back millions of years and then billions of years, we don't see modern humans beyond 200,000 to 300,000 years. We see proto-humans before that. We see the transitions, I believe, between us and the earlier species. The thing that would falsify it would be if something turned up different than that. If we ended up seeing a modern human alongside an Australopithecine or earlier, we just absolutely never see that. So,
can I add something?
Yeah, definitely. Go ahead.
There were a lot of things that Fuzz Rana said that I disagree with, and one in regard to the Cambrian explosion. I've read some articles about it. And as you can, like this one, which says our results using updated methods on morphological and genomic scale data show potentially even greater congruence. Inexplicably fast rates are not required to explain the Cambrian explosion of arthropods, even using under an extreme scenario in which all divergence are compressed into the Cambrian. So I don't know what he's talking about, that there is no a valid explanation for the Cambrian explosion under the evolutionary model.
Fuzzy, do you want to address that real quick? I don't remember you bringing it up, but maybe
the image was appearing backwards for me on my screen, so I wasn't able to capture the details of what was being said there. But I'm not saying that nobody has proposed ways to try to explain or account for what's happening in the Cambrian explosion. But when you look at the literature in its totality, I think there is not really a compelling explanation for what accounts for this explosive appearance of disparity in the fossil record, where you have in a geological instance, the origin of a significant number of animal phyla that, you know, essentially document the animal phyla that have existed throughout Earth's history. And we really don't see animal phyla, for the most part, appearing after the Cambrian explosion. And so this is enigmatic.
You made two points. I want to stay on track. You said we don't see any new phyla appear after the Cambrian. That is simply explained by the law of monophyly. You cannot have a new phyla appear, because once you add it, you need to have something evolving out of its ancestral phyla, which is evolutionary impossible. And one of the points you made before that, I can't remember now. What did you say before that, when you said no new phyla appeared?
I said in essence, no new phyla appear. You could make an argument that there may be.
No, I remember now. You said in a geological blink of an eye, all phyla appeared, right?
Geological instant, yeah.
Yeah, but in terms of biology, that is a vast amount of time.
Yeah, well, I mean, when you're looking at the Cambrian explosion, what the place to go is the Shangjiang fauna in the Yunnan province of China. That's looking at the lower part of the Cambrian, and you see basically an incredibly rich Lagerstätten of fossils that show up at the lower level of the Cambrian explosion. That's essentially describing all the animal phyla that would have appeared in the Burgess Shale, and even more so. And so you have, in a sense, the complete Cambrian event documented at the lowest parts of the Cambrian layers. And so I would argue that you're looking at a window of time that is on the order of a few million years. You don't have the entire duration of the Cambrian for the Cambrian explosion to unfurl. It's happening and documented at the lowest levels of the Cambrian.
Okay, let's go ahead and go on to the next question here. Did that satisfy you for right now, Neslig?
Well, I have one thing to add to it. Yes, you have in the earliest phase of the Cambrian a lot of things appearing that didn't appear before, but we had also a lot of things appearing after it. For example, in the earliest phase of the Cambrian, you didn't have trilobites yet. These appeared in a later phase of the Cambrian period. And that's just
okay. This one's a little bit more going to be a little more complicated question, so we might have to take a little more time on it. I'm going to ask this one to Bill first, if that's okay to Fuzz. How does complexity relate to human evolution and intelligence, and by what do we measure it to determine complexity?
Okay, I think I understand the question. You know, if we're talking about complexity as intelligence, right? I mean, as far as well, I mean, what we see, I believe, is we see, you know, complexity evolving right alongside cranial capacity with hominins. We see spikes in intelligence or complexity. We definitely see it right around the time of Homo habilis, early Homo erectus, with tool use. We see another spike happening about 40,000 years ago, where we first see really art and religion taking shape, that type of thing, abstract thinking. And then we see it again with the civilizations starting 10 to 12,000 years ago, and especially 5,000 years ago with the invention of writing, where, you know, with the invention of writing, we could really start to build on the shoulders of the people that came before us and accumulate knowledge, not only accumulate knowledge, but pass it on to other people. You know, throughout evolutionary history, I mean, we started with things like simple tools. You know, I mean, we see Australopithecines using things that aren't really much different than what a chimp would use. They would pick up a stone tool like this, something maybe that fit in your hand, and use it to, you know, smash up nuts or whatever. We see after that with Homo habilis and the Oldowan type stuff. We see the early hominins, we see them picking up a different type of rock maybe. This is obsidian, choosing the rocks, but again, making crude tools. And then we see a huge spike when we get to Homo erectus with the invention of the hand axe. And that technology was around for over, you know, 1.5 million years. This is actually a Paleo Native American hand axe that's about 10,000 years old, was discovered right here in Arizona. But we see that is something where they started to make tools with an end product in mind, instead of just, you know, randomly picking something up or breaking rocks and using it. We definitely see complexity evolving at that point. But, you know, it was a long time. It was a gradual process. We see stone tool technology staying the same for roughly over 1 million years. And then it wasn't until, I said, like about 40,000 years ago that we really see modern humans in their current form, not just anatomically, but mentally or intellectually, start to take shape with art and religion. And then I just believe that the invention of writing was the thing that really kicked it off 5,000 years ago. You know, that again, we were able to build on those that went before us. So.
Okay, same question to Fuzz. How does complexity relate to human evolution and intelligence, and by what do we measure it to determine complexity? Specifically, is there a way to quantify it? Is there a way to quantify complexity?
Yeah, well, you know, and I would take a little bit of a different perspective on the archaeological record than Bill. There's a lot of work that's being done as to what really demarcates behaviorally modern humans from other hominins and other creatures, such as the great apes. And anthropologists have basically identified three capacities. One is our capacity for symbolism. That is, we can represent the world symbolically and then manipulate those symbols in our minds and communicate with one another symbolically through language, both written and ephemeral language, that is through speech, through art, through music, even through body ornamentation. Another property is what's called theory of mind, which again looks to be unique to humans, just as symbolism looks to be unique to humans. That is, that we recognize that others have minds like ours, and we can actually anticipate what they're thinking, even anticipate their emotions. And then finally, we have this capacity to form extremely elaborate social networks. And when you put it all together, that creates a combination of properties that really demarcate humans in a significant way from other hominins and from the great apes. And in fact, there is a minority of anthropologists that are embracing this notion of human exceptionalism, where the argument is that humans really are different in kind, not just simply different in degree, and that the behaviors that people have traditionally viewed as being antecedents to the behaviors displayed by modern humans are actually qualitatively very different types of behaviors. That animal communication is not an antecedent to the capacity for humans to communicate in symbolic manners. Now, Bill makes reference to this idea of the sociocultural Big Bang about 40,000 years ago. That idea was based primarily on the archaeological record in Europe, and it was a very Eurocentric view of human origins. Just recently, there's been discoveries of cave art all throughout Southeast Asia that is identical to the type of cave art that we see in Europe, which basically now forces you to place the origin of that capacity for symbolism back to before humans began to migrate out of Africa. We've got cave sites in South Africa that show symbolism, artifacts that display symbolism that were produced by modern humans, and there are much more spotty archaeological sites that are more controversial that even push that origin of symbolism closer and closer to the time where we think modern humans originated. And in fact, people like Ian Tattersall, Guinevere van Petzinger, for example, think that the very first modern humans were identical to us in their capacity. And there was the Neolithic Revolution, there was the invention of writing, but these are not biologically driven inventions. These are basically cultural evolution. And in fact, Guinevere von Petzinger has argued that if you examine the cave sites in Europe, and in Asia, you actually see these symbols, these proto-symbols on the walls that she thinks represent the very first writing. And there's like a collection of about 30 symbols that are consistent from cave site to cave site. But she's arguing that there's actually proto-writing that goes back as early as the time in which we were beginning to express ourselves artistically. And so I would argue that this sociocultural Big Bang actually drifts backward to very close to the time that modern humans appear, and that it demarcates us from other creatures. And it's clear that the hominins in the fossil record are doing some amazing things in terms of their behavior. But what's very interesting is work done by a number of primatologists. Jill Pruitt's at Iowa State is one who's probably done the most impressive work, where they've observed chimpanzees in the wild over the last decade. And chimps are doing some pretty remarkable things. They manufacture spears from tree branches that they'll use to hunt bush babies. They will manufacture beds in trees, and they'll select branches that have insect repellent properties. They put the trees in strategic locations. They will occupy cave sites seasonally. They make stone tools. They make tools, of course, to extract termites from nests. They will make tools to actually fish with. They actually understand, according to Jill Pruitt and some of the observations she's made, they actually understand the behavior of fire and can actually exploit fire, believe it or not, for their purposes. They can't capture the fire opportunistically, but they do seem to understand it and are able to exploit it. And so when you take that behavior and you overlay that behavior on what you see Homo habilis, Homo erectus, and Neanderthals do, it really makes these hominins qualitatively cluster in terms of their behavior much closer to that of the great apes than to humans. It really does look like humans stand apart in my perspective, and the qualities that make us stand apart, in my view, align with the biblical concept of the image of God. I would see symbolism and theory of mind and this capacity for complex social networking as a scientific description of the image of God concept.
Well, let me ask you a question in regards to this particular question that kind of relates to the last one as well, though. If there was, for example, chimps that are starting now, they say to be pre-Stone Age or something along those lines, if they did develop some kind of communicative abilities and a social network to rival our own, would that be able to be incorporated in the RTB model, or would that kind of falsified if they were sentient, aware, self-aware, and had a civilization to match something that we have as Homo sapiens sapiens now?
Yeah, that's a really good question. And I think the answer would be if you had evidence that chimpanzees were symbolic, had theory of mind, and again formed the types of social networks that we form. Of course, these creatures are interacting socially, and they are intelligent. They have emotional capability. But I would argue that it's the combination of factors that just seem to make human beings stand apart. If you could show that human beings really were not unique in kind, or different in kind, but only different in degree, I think that would be I don't know if it would falsify the RTB model, but it would be really a serious blow to the model, in my view.
It'd be challenging.
Yeah, or it would force a revision of the concept of the image of God in such a way to align with it. But that revision of that concept would be in contradistinction to what Christians have historically viewed the image of God to entail. Now, for example, groups like Biologos that are evolutionary creationists really struggle with what exactly does the image of God mean. And so they're looking at redefining the historic understanding of the image of God to accommodate what they see to be an absence of human exceptionalism. But I would be uncomfortable with that. I think if you or if you're going down that path, you are essentially very close to falsifying at least the RTB model, and it's going against a traditional historic understanding of human exceptionalism from a biblical standpoint. But I think that might be a place where, if it didn't falsify it, it would represent, in my view, a rather serious blow.
Okay, I think Dragnon, are you there? Because I think you had a question from Rational Mind that you wanted to ask. I don't have his question.
Yes,
so
I got his question. So
yeah.
basically, Rational Mind wants to know what Fuzz thinks when we don't see any discontinuities in the phylogenetic data.
I'm sorry, I don't quite follow what that question means. Could you try to maybe frame it in a different way?
Yeah, hold on. I was reading it the wrong way. Can someone in the Hangout ask Fuzz why he thinks we don't see any discontinuities in phylogenetic data?
Oh, okay. I think I understand what you're asking. If not, please, I'll try to go quickly. If I'm missing the mark, please come back and ask the question again. You know, I would argue that phylogenetic trees are not evidence for the evolutionary paradigm. They are an interpretation of shared features from an evolutionary perspective. And so you have to think of phylogenetic trees as being evolutionary hypotheses about how organisms relate to each other, as opposed to actually evidence for the evolutionary paradigm. And you can take, for example, silverware in a silverware drawer, and you can actually organize the silverware in that drawer using phylogenetic trees, creating these hypothetical evolutionary relationships among the pieces of silverware based on their shared features and their distinct features. In fact, you can go to some place like Taco Bell, for example, and get a spork, right, which is a combination of a fork and a spoon. Yeah. And you could even argue, well, this is, you know, evidence of some kind of transitional form, you know, buttressing an evolutionary interpretation of the phylogenetic data. And so all that is somewhat of a, you know, again, tongue-in-cheek example, but all that to say is that it's possible to take anything that shares common features and organize it or interpret it in an evolutionary framework. Or you could look at those features and say those shared features reflect common design as opposed to common descent. This is how Sir Richard Owen, who...
I have a...
I think, let me try to clarify.
Okay, wait a minute. One more point. And then, but to say that these phylogenetic trees, again, are continuous, I think isn't exactly true, because one of the big problems plaguing evolutionary biology are incongruities in evolutionary trees, where trees built with morphological data don't match trees built with molecular data. And when you're looking at different regions of genomes and you're using the different regions of genomes to build these trees, you still get incongruities in the trees. In fact, when you look at the relationship between humans, gorillas, and chimps using whole genome comparisons, 22% of the human genome much more closely aligns with that of the gorilla than with that of the chimpanzee. So I would argue that these discontinuities are, you know, again, are troubling from my perspective as an old Earth creationist for the evolutionary paradigm.
Okay, I have there was a bit of a clarification that I missed. I'm sorry, I misread the question while trying to talk to my wife at the same time. To clarify my question earlier, it's about the universal common ancestry. Surely, if there was were different created kinds, then there would be discontinuities in phylogeny, while human common ancestry would predict the opposite. In other words, there should be branches between particular nodes in the tree that are incredibly inconsistent if they represent non-existent links between unrelated kinds. And so that's a bit. Like I say, he wanted to expound upon that a bit more.
And clarify a little bit.
Actually, address that question.
Buzz, do you think there are discontinuities in the phylogenetic record?
Again, I'm not quite sure I know what was meant by discontinuities, because you can take any collection of organisms that have shared features, and you can connect them in you know, a large number of different possible ways from an evolutionary perspective based on those shared features. You know, and I think the work of Sir Richard Owen prior to Darwin is really instructive here, because you know, he's the one who actually played a key role in developing the concept of homology, and he did it from a design-oriented type of framework where he argued that there was this archetypical design that existed in the mind of a creator, and that organisms that naturally would group together that shared, again, these common design elements or these common, you know, anatomical and physiological elements reflected varying manifestations of the archetypical design. That's how he interpreted it. And Darwin came along and supplanted Owen's archetype with a common ancestor. So I don't know that I would actually agree that there are these continuities in phylogenetic trees. I think the continuities are simply an artifact of interpreting the data in an evolutionary framework.
Well, I think part of the issue here is that, you know, the time period that you're referencing was before the advent of modern genetics. So, I mean, we can talk about the morphology all day long, but the genetic data is absolute. There is no interpretation with genetic data in respect to organisms will share, you know, greater portions of the genome with others.
So, Jack, you're saying there's a continuous or contiguous thing in the genetic record if we actually look at the genes itself from one branch of the phylogenetic tree to another.
Right. If it was just based on morphology, then that'd be one thing. Then we could tell, like, through genetic analysis, you know, doing, I guess, I don't know, some different types of sequence alignments that even I'm not familiar with, that we could see that, okay, well, isn't this organism because of said genetic data, but we see the exact opposite. We see that they are similar based on that genetic data, but oh, by the way, their gross anatomical features also tend to look like other members of the ones that are within their species or genus, so on and so forth.
Yeah, and this is where I would bring up the idea of these incongruent evolutionary trees, because even when you're building the trees using genetic data, you wind up with incongruities. And again, the example I brought up was the comparison of the gorilla, chimpanzee, and human whole genome sequences. 22% of the human genome aligns much more closely with that of the gorilla than it does with the chimpanzee. That would be an example of an incongruity. And in fact, I had a conversation a number of years ago with Francis Collins about this very point. And this was before people were doing whole genome comparisons, before they were doing phylogenomics. They were still at a time when people were doing phylogenetic comparisons. And he said, well, those incongruities are going to basically disappear when we start doing whole genome analyses. And lo and behold, a few years later, people showed that even when you move to phylogenomics, you still suffer from these problems with incongruities in evolutionary trees, even using whole genomes as part of that. And I don't have the reference off the top of my head here, but I did write an article that discusses the paper in which that result was reported. It's available on our website. I can post a link on my Facebook page or something after the broadcast if you're interested. I think it's something like DNA sequence is more or is not better is the title of the article that I wrote. But again, I would argue that the incongruities in phylogenetic trees argues against this idea of continuities.
You know, I think actually that particular topic is actually deserving of a hangout unto itself. With some other people, including some people we haven't here, and other people that I know that are very much interested and experts on that particular topic of the genomic analysis of chimps and gorillas. But I think, Jade, you have a special thing on this as well in knowledge. Do you want to add to that real quick?
Yeah, and first of all, I'm going to point out what Nestling said, which is basically where I was going, but I was going to give a real simple example. And he said to point out that the 22% closer to gorillas is about incomplete lineage sorting and gene flow after divergence. So let me give you it's actually really easy to do this graphically, but I hope you can follow with me. So of the common ancestor of humans, chimps, and gorillas. This common ancestor had traits A, B, C, D, E. So when gorillas split off from the human chimp ancestry, they both lost the E, but gorillas kept the A, B, C, D, and so did the common ancestor between humans and chimps. The common ancestor of humans and chimps also had the A, B, C, D. However, when chimps split off from humans, the chimps lost the D, and we lost the C. So chimps are now A, B, C, be D. So we have the D that gorillas have only because in the split between humans and chimps, chimps lost that trait. So this is how this happens. It's not really an incongruity. It's just a matter of what happens as things split off. Certain things are lost. So we retain certain things from the common ancestor of humans, chimps, and gorillas that gorillas have. But when we, those traits were also in the common ancestor of humans and chimps. But when humans and chimps diverged, chimps lost certain things, and we lost certain things. But some of the things that we kept, gorillas have, but chimps don't. So I hope that makes sense.
May I just jump in real quick? Yeah, I'm aware of this idea of incomplete lineage sorting as a way to try to resolve that problem of that incongruity. But my understanding is that incomplete lineage sorting is essentially applying to speciation events, and you're looking at gorillas diverging from the lineage that produced humans and chimps, I don't know what, 10 to 12 million years ago. And you're also, you're making assumptions that there are not decreases in population sizes, or that there's not these populations passing through, bottlenecks. And to think that there wasn't these dynamic fluctuations in population sizes doesn't seem to be a very realistic scenario from my perspective. And you also have to assume that there was a rather large population size that was retained throughout that entire evolutionary history. And I don't know that there's any data that supports that. So I'm aware of the idea of incomplete lineage sorting, but I'm highly skeptical that it actually resolves this problem.
Well, first of all, Steve, could you highlight Nestlink? Because Nestlink has a graphic representation of this, which is why I said it's really easy to look at graphically, if you can see how these traits follow. So if you look at the yellow, you can see how humans have the yellow, but chimps have lost it. That's just an example. Well, I don't see why population size is a problem. We have evidence that humans went through at least one population bottleneck. If anything, a population bottleneck would help to narrow certain traits. So maybe we lost the D, as I was talking about here, through our population bottleneck.
Yeah, that might be on backwards for his screen, but I'm probably sure.
You did a marvelous job describing incomplete lineage sorting without a diagram. I was impressed.
Well, that's what I was trying to do. It's difficult. I wrote it down on a piece of paper to see if it made sense. But yeah, I was just trying
Sam,
to.
Sam, do you want to add to this particular thing real quick, Sam? And then we'll get the last question, and then we'll have more of a free form. So
well, I mean, I think part of the issue that I have with what Fuzz is saying is a lot of, and I mean, this goes for a lot of what he says, but in this particular issue where I'm a little bit more informed, it seems like it's easy to say that these methods don't accomplish everything, right? That it's easy, in the same sense, it's easy to say the world is not my pony, right? But the issue is right, any statistical method, in genetics is going to be, it's going to be imperfect because we don't have perfect data. My question for Fuzz related to this is there any point at which he's going to ever be satisfied with these models if they're not 100% accurate, or is it just a way of holding out doubt, let's say?
Let me respond to that, because the way that this conversation is going is kind of forcing me into scenarios where I'm critiquing the evolutionary paradigm. And really, the approach that we take at Reasons to Believe, and the approach that I take personally, is not to simply spend all of our effort, taking pot shots at the evolutionary paradigm. Rather, our approach is this: that if we take the traditional biblical view of human origins, and we feel as if the biblical text demands that God is creating through a process of intervention, at least at distinct points in the history of life on Earth, can we accommodate the data that exists in a creation model framework? That's the primary focus of what we're doing. it's our apologetic isn't evolution doesn't seem to explain this, therefore I'm a creationist, but rather it's I'm a creationist for a whole host of reasons, and because of those reasons, can I now interpret the nature of the scientific data in a way that the creation model accommodates it? And then the question is, well, why not interpret it from an evolutionary perspective? And it's at that point I would point out places where I think there to be deficiencies in the evolutionary paradigm, that it doesn't have this all-explanatory power, that there are places where the paradigm fails. And it doesn't mean that those deficiencies in and of themselves are enough to reject or falsify the evolutionary paradigm, but they're enough to basically garner some measure of skepticism as to, is this really the best way to explain all the evidence at hand? You know, I will play the game from time to time. What happens if I would embrace evolutionary creationism? Well, number one, it would create some biblical and theological issues. But that aside, I still would look at the data at hand and see things like the origin of life that just simply defy explanation. I would still see the problems that I see with the evolutionary paradigm. And in some instances, I'm not really sure that evolutionary theory as it currently exists is sufficient to solve some of these problems. It's not just simply rolling up our sleeves and just pressing harder on these issues. There seems like there really needs to be some kind of genuine innovation in evolutionary theory to get around some of these issues. If not, I think it's reasonable for somebody to say design is just as good, if not maybe a better explanation. And so, again, I'm not trying to evade your question, but I think I'm being forced into a situation where I'm critiquing the evolutionary paradigm, and then with the assumption that somehow that critique in and of itself is the sole reason why I hold to the views that I hold. Does that make any sense?
It makes sense, but I would say that that's kind of, and again, like this is going to come out wrong, but it kind of seems like it's playing the game unfairly, right? So when I go into the lab and I'm looking for an answer, I want the most honest presentation of the data. And I want, let me rephrase, the most straightforward explanation of the data. Whereas it kind of seems that what you're doing here, to address what you're explaining first, is you said, well, I have this conclusion, and then, okay, how do I concord the data with my interpretation of the data with that? And to me, that seems rather backwards. To wit, you wrote an article about, and I don't have it on hand, on Reasons to Believe, where you were talking about the Y chromosomal atom and mitochondrial Eve and how they could be literal people. And that, and you cited that, oh, look, population estimates are not 100% accurate on these things, and they can underestimate heterozygosity. And I thought, you know what, that's really a good point. And I looked into it, and I looked into the model that you had cited. I looked into your citations. Well, it turns out that the model that you had cited had underestimated heterozygosity in that population by 4-fold. Now, that's less than half of an order of magnitude. Now, from 2 individuals into, I think it's the current estimate's roughly 10,000, 30,000 individuals at the time of mitochondrial or Y chromosomal atom and mitochondrial Eve. We're talking instead, 4 orders of magnitude. And so there's almost no, pointing out that these models aren't perfect, which is what you did, and fairly, by the way, in that article, that's not a justification for your conclusion. And I've seen that in quite a few of your articles. And so it kind of seems like, do you, as, if I was to ask you as a scientist, right, if you went in and you said you knew that a certain biochemical mechanism, since you're a biochemist, was the case, right, but you needed to find a way to make the data fit it, how would that sound to you? And I think that's because it's not clear to me in the context of, again, Y chromosomal atom, and I'm just using this as an example, you didn't present an alternative model. You sort of cast shade against the current estimations. And that's kind of what I see from a lot of your articles, where it's you say that your job isn't to cast shade, but it kind of seems like that's the only thing that's ever being done.
Okay, well, and I would argue that, these articles are meant to be highly focused discussions on a particular issue. And when you look at the apologetic that we present in totality, like, for example, in the book, Who is Adam? The emphasis in the book is strongly on our model and the predictions our model makes, and are those predictions satisfied by the data at hand? So I would argue that, in totality, we're not emphasizing that, but you could pull out isolated articles where I'm addressing a particular issue or a particular concern, and it may seem like we're doing that in isolation. But I think your question is a fair question and a fair point about, again, are we just coming up with a conclusion and then doing everything we can to justify that conclusion? But honestly, I see that same thing happening in the scientific community. And I was just a few weeks ago at the 18th International Conference on the Origin of Life. And, this is the third conference I've been to. The last conference I was at was 15 years ago. And literally, you could have taken every paper that was presented at this year's conference and presented it in 2002, and it wouldn't have been out of place. You wouldn't have even noticed the difference. Or you could have taken every paper presented in 2002 and presented it at this year's conference, and they wouldn't be out of place. There was literally zero progress being made in the origin of life question. And the fundamental problem is, while there is very good work done in prebiotic chemistry in a laboratory setting, identifying reactions that in principle could contribute to the origin of life process, those reactions don't translate to the conditions of the early Earth. The conditions of the early Earth are much too uncontrolled, much too variable, much too chemically and physically complex. And origin of life researchers readily acknowledge it. I had lunch and dinner with a number of origin of life researchers, and we would have these discussions. And there was just this dogged commitment that even though we don't have explanations, even though we're hitting a dead end after dead end after dead end, we're going to insist that evolutionary explanations are the way to go. And the irony is, at this particular conference, the one thing that was actually what I would consider to be actually something unique to this year's conference was actually an emphasis on synthetic biology, where researchers are trying to create protocells in the lab and realize that work overlaps strongly with work in prebiotic chemistry. So there was a number of presentations on synthetic biology. And when you look at that work is showing how critical intelligent agency is in pulling off even the most simplest systems that begin to approach some kind of protocellular entity. So here's empirical evidence that points to the necessary role of intelligent agency. And so, my point would be, I see the origin of life community not following the evidence where it goes, but actually already having determined what the conclusion is, namely that chemical evolution generated life, and refusing to budge from that position and trying to take everything that they generate and interpret it in the best possible light, or dismiss results that just simply don't go in their favor. So I see that same kind of attitude actually at least in pockets of the scientific community. So yeah, I could be accused of being guilty of that, and perhaps I am, but I don't think I or reasons to believe is necessarily unique in that sense.
Well, I mean, just because my brother punched my younger brother in the face, it's right for me to punch him in the face. I say that, I'm being facetious, of course, but I think saying other people are doing it is not justifications for your actions. But the other thing is that I don't want to call into question your interpretation of the conference or the participants of the conference, but I get email blasts from most of the major journals every week, and I've seen quite a few articles, some that I've shared with, well, I guess Dragnot left, but I've shared with him on Facebook of recent advances, and Current Biology actually published an editorial on a lot of these recent advances. For example, one had an effective kinematic and biochemical modeling of the I don't want to question the quality of either your interpretation or the conference, but I have to disagree. There has been work done. The second part is, you've made this claim that, oh, well, let's just say we're hitting dead ends. I don't agree with you on that. I think that that's a vast misstatement of the literature. But let's say that we are. I mean, in the late 19th century, we thought that we had solved every problem in physics. We thought that, Newton solved everything and we just had to move forward from that. And then, oh, lo and behold, by further naturalistic, and I want to highlight that naturalistic investigation of phenomena, we have Einsteinian relativity and quantum mechanics. Just saying that we've hit a dead end now and we need to introduce this, a supernatural agent. I don't think that that's, I don't think that the track record of science would justify that. But B, I would feel more comfortable if you guys were producing experimental results. You can say, well, this might be explained by, a creation model, but I've yet to see a creation model that is testable. For instance, you're citing as evidence of a creation model, a research construct. Well, then, yeah, we can't do research because humans have to design the construct. I mean,
Buzz, you want to quickly respond to that quick?
That's all I had. I mean, he
those are good points.
He kind of had like 4 minutes, but
Yeah. Well, yeah. We can move on. We
only have an hour. So the next question I got to tell you, I just for the transparency's sake, I have asked Buzz before, so he is aware of this question weeks ago when I had asked him on his Facebook, which he was kind enough to answer. And by the way, so he actually did address the concerns with things like ribosomes and other things in progress with Origin on his weekly show on Facebook. I think was it called Q&A Monday, Fuzz? What's it called?
Question of the week.
Question of the week. That's it. I'm sorry.
Any more inventive than that?
No. Hey, my show on Sunday is called the Sunday Show. So coming up with names, not my thing. I'm not very original, but he did address this particular question before, so he might have a slight advantage to it. But let's get to Bill on this particular question first. What are the differences you would expect to see if humans were teleologically versus teleonomically designed? And that you guys, after he has this, and then Fuzz, if you guys want to address this or suss it out a little bit more, because I think this question is one of my most favorite questions, and I think it really pertains directly to both the RTB model and the differences of the modular synthesis, because one kind of obviously requires a teleological approach and the other one a teleonomical approach. So Bill, go ahead. You can go first, and we'll toss it over to Fuzz.
Yeah, this is one of the hardest questions, probably the hardest question I thought, because I just don't see the appearance of design. You ask, what difference would I see? Well, I would expect to see something totally different than what we see, in the fossil record and in the genetic record. I would expect a sudden appearance of something totally different, but I don't think we see that at all. I think we see it all going back to one source. I don't see irreducible complexity in anything. I think that there's some things that we haven't answered yet, but I just don't see it as being an issue, especially for the theory of evolution. So, that's the big issue I see, is I just don't see the evidence for design. I don't think there are any gaps that we won't be able to cover in our knowledge that we have.
Could you think of any way, Bill, that if it was teleologically designed, could you think of a way to determine that, or you just don't think it's possible at all we could ever make that distinction?
Well, again, I think, to falsify it or to as evidence for that, I don't think we would see the phylogeny. I don't think we would see the homology. I don't think we would see the continuation that we do see. I think you would see things, and I didn't speak much myself on the Cambrian explosion or anything, but I mean, I don't see that any of that as an issue. I think you would have other gaps. You know what I mean? You would have in between that and now you would see sudden appearance of something totally different, and I don't think we see that at all. Okay,
Fuzz, to you.
Well, I think this question that you're asking is really a very important question, because if it was if the human body is again described in teleological terms, you would expect elegant, sophisticated designs as par for the course. If it's teleonomy, where it's the superficial appearance of designs, you would expect that those designs turn out to be flawed. And so I think that would be actually one very potent way to discriminate between the two models is, are the designs, you know, elegant and sophisticated, or are they ultimately fundamentally flawed in some way? And in my book, The Cell's Design, I kind of address that concern at a biochemical level. I'm you know, not a human anatomist or physiologist, and so that's something that's just simply outside my area of expertise. But you know, the principles that I laid out in The Cell's Design, I think, would apply here, and that is, you know, many times when I see people pointing out so-called flawed designs in the human body, these are obviously complex systems that we don't have complete understanding of, and many times what we thought was a bad design turns out to have a very good rationale and a very good explanation as we learn more about that system. That is, what seemed to be a flawed design turns out to be an elegant design. Or sometimes there are genuinely suboptimal designs in biological systems, but those suboptimal designs are actually reflecting a balance of trade-offs that the system simply is confronted with. And so the suboptimal designs reflect, again, trade-offs and the necessity of trade-offs as opposed to a genuinely bad design. So I think, you know, that to me is a very big issue for the design argument. Is, you know, are systems sorry, I can never say that word. Are they best described by teleonomy or teleology? And so a lot of the effort that I spend in my work here at Reasons to Believe is to take examples of systems that people have declared to be bad designs and try to analyze those systems based on what's in the scientific literature and try to point out that what appear to be bad designs turn out to be good designs. But I think that would be a really good discriminatory test. Now, I don't think things like disease or injury, you know, are necessarily count against the quality of a design. I mean, oftentimes I'll see people talk about the human spine is poorly designed because people suffer from back injuries. You know, I don't know that that necessarily reflects a poor design, necessarily speaking. You know, but I think that's a great question, Steve, and really I think a point that could be used to really discriminate the models.
Bill, do you want to expand upon that a little bit?
No, I'd like to move on if we could. I do have some questions for Fuzz if we could.
How much time you got left there, Fuzz? Because we're well over.
But I need to be out of here by 11.
Okay.
So 15 minutes.
Okay. So yeah, another 15 minutes or so. 20.
Okay. So well, go ahead, Bill.
A couple things. I mean, how you have the ministry with Dr. Hugh Ross. Are you guys in pretty much agreement? I mean, if he has a presentation, he makes statements. Are you pretty much in agreement with what he says, and vice versa? Or?
In a broad sense, yes.
Okay. Yeah. And I haven't read any of your books. I haven't. I've watched some of the presentations. Okay, and I've seen some of the YouTubes. How old is this? I saw an 1.5-hour presentation that was very well done. It was called Through the Lens of Evolution. How old is that presentation? You know?
Oh gosh, it's been a number of years ago that we recorded it.
It's really hard to tell because people upload things on YouTube, and I saw it. I think it was uploaded in January of 2017. So it wasn't on your channel. I'm sure it was on someone else's. So
somewhere guessing 7 to 10 years ago, maybe.
Okay, it was that long ago. Okay.
I'm about 7 years ago, plus or minus.
Okay.
I don't remember.
Okay. My concern is when I viewed that video, I saw you were brought up, there's 5 types of evolution, microevolution, speciation, microbial evolution, macroevolution, biological evolution. I mean, it was almost like Hovind with his 6 different types of evolution where, we have all these problems with these ones. But again, when we're discussing macroevolution and we're discussing human evolution, we're not discussing the origin of life, and I see that being stressed a lot. That you can't basically go on, and evolution has no foundation unless you can discuss, show how the origin of life is, and I just don't think that that's fair. Discussing human evolution. Again, and you had mentioned, and this was a quote, when scientists study nature, they pretend as if God doesn't exist. Well, that's the nature of science. We don't inject the supernatural. I mean, it is methodological naturalism, but it is also, that's absolutely the nature of science. So it doesn't deal in the supernatural at all. In that presentation, I didn't see any alternatives to evolution presented. I saw it as a step-by-step kind of methodical, here's some of the issues of evolution. I saw quote mines, I would call them quote mines, of Charles Darwin and Stephen Gould. I saw you claim that the Cambrian explosion lasted 2 to 3 million years, where minimum I see everywhere else is 20 to 25 million years. Some people will say it lasted now 70 million years. So we have fossil evidence going back into the Precambrian. So just some concerns. And I watched a video. The reason I asked you about Hugh Ross, I watched a video on Hugh Ross where he was talking about Neanderthals, and he claims that Neanderthals were really no different. I think his quote was they were akin to orangutans or chimpanzees, and that their tool use was barely above what a chimpanzee was using. Where again, it's a whole different. In my mind, I see something totally different. I see them creating tools with an end product in mind. We don't see that with chimpanzees, other than maybe the sticks that they clean off or whatever. But I see it as a whole different level. Again, I saw claims that modern humans, everything just shows up explosively when they appear on the scene. But I see a gradual change over millions of years. So anyway, I just wanted to know, I mean, you guys do have an alternative then? I mean, because I didn't see it in the video presentations I watched. Hugh Ross made the comment that he actually admitted that what he has isn't biblical. So, I mean, if it's not biblical, I can at least understand the young earth creationists with their biblical literalism, because you can go to the Bible and see what they say. But if you disagree with the modern theory of evolution and you're not a biblical literalist, what do you call that in between there? So that would be my question for you.
Yeah, well, I mean, our position is old earth creationism. And so we would argue that the Genesis 1 creation account and other creation accounts found in Scripture are descriptions of God's creative activities, that Genesis 1 is a divine natural history of sorts. So we would agree with young earth creationists on that particular point. But we would argue that day is understood as a period of time. The word yom in the original Hebrew can mean a period of time, or an eon, or an epoch. And so we would argue that what's being described there are 6 epochs. It's not an exhaustive characterization of what God has done, but it rather are highlights or snapshots of God's creative work that I would argue are organized more or less chronologically, though I think there is a topical nature to how those snapshots are organized as well. So that's how we're viewing it. So we would argue that our position is a literal reading of Genesis 1, but it's not a concrete reading of Genesis 1. That is, we're using that term literal reading in a hermeneutical sense, that we're taking into account the nature of the literature, the original language, as best as we can, and we're saying that this is what the text is literally saying with those within that context or within that framework. So, and then from that we're trying to derive some understanding of what nature ought to look like if indeed there is a creator, and indeed that creator orchestrated the history of life on earth. And so in doing so, we produce basically creation models. We've got one for the origin of life and one for the origin of humanity, and we're working on other models in between that.
Hey, real quick, thank you for that, Fuzz. I have somebody here that I know you know. He's actually new to the Great Debate Computer. He's actually really new. Pastor Kenny Rhodes. I believe he's PhD in theology. Is that what it is? Kenny? Can you hear me, Kenny? You there? I talk? Can you guys hear him? I can't hear him. Uh-oh. I don't think your mic's working there, Kenny. We're going to have to figure that out. Uh-oh. Well, long story short, I believe today Kenny's going to be joining us at 2 o'clock to kind of have another kind of informal discussion. Fuzz, since he can't talk, his mic's not working. While he's figured that out. Do you know about him because you've known who he is? Do you want to give it his background a little bit?
Well, you're dealing with somebody who is a consummate theologian and philosopher. So he's a really, really sharp thinker. So I think you guys will enjoy interacting with him. He's a really good guy.
If we can get the mic working, right?
Yeah.
I do have to end this. Obviously, I know you have to go, Fuzz. Let me give you guys at least like 1 minute each to kind of close it up, and then I'll give my closing. And then Kenny, we'll figure out your issue, and then I guess at 2 o'clock when we have you back on, we'll kind of have a dialogue. So, anyways, Bill, you want to go first? Take your minute, then we'll give it to Fuzz, and then I'll end it.
Sure. Yeah, I don't have much more to say. I mean, my biggest concern is if we plug in a supernatural being, we plug in a God into the gaps where we have gaps in our knowledge. I mean, what's the reason to keep looking for it? I think we've just barely touched the iceberg. I mean, we've made more strides in, say, finding fossils in the past 30 years than we did in history. So, and we're finding genetic evidence now, and the gaps are filling as extremely quickly right now. And I think eventually it's going to push the need for any kind of intelligent design or supernatural being right out of there. We may never discover the origin of life. We may never discover, what happened before the universe was there. But I think other than that, I think we're going to have a pretty good handle, I think, on where we came from. And that's going to help us know where we're going. And I just think it's really important. And, I just don't see the need to interject any kind of supernatural anything into it, and I think that has the chance of stifling research and going forward with it. So,
yeah, and I would just respond to that by saying I don't think taking a design/creation model approach to science necessarily would stymie scientific advance whatsoever. I mean, when you look at the history of science, many of the very first and most prominent scientists in the early history of science were motivated by their Christian faith to actually pursue an investigation of the world around them, because they saw that as essentially a way to think God's thoughts after him, so to speak. And, I would argue that there are areas of science where intelligent design is already a part of the construct. I think archaeology is a beautiful example of that, where we can determine whether or not a stone is shaped by an intelligent agent or by natural processes. And that, determination, that discrimination between natural processes and, again, intelligent agency is really very critical to the whole enterprise of archaeology. And when you look at synthetic biology, when you look at things like biomimetics and bioinspiration, which are engineering disciplines, those are, in effect, intelligent design programs where we're taking our understanding of biological systems and we actually are thinking about those biological systems in design terms, and then taking that design framework and then using that as inspiration for technology development. And these are two very exciting and very fruitful areas of technology development and science. So I think intelligent design is a very constructive approach to science. I just don't think that the questions you ask in an ID framework are the same questions you ask in an evolutionary framework. And I think that's perhaps, Bill, your concern. But I think you still are in a position to drive scientific advancement, even if you believe that there is a supernatural agent that is responsible for features of the world.
Thanks, Buzz. I think it works. We didn't kill Kenny, guys. I think I hear his mic. Yeah, we can hear you. You want to add something real quick before I end this? We got about 3 minutes. It'll take about 30 seconds to introduce yourself. Then I'll bring you back on later on today.
Yeah, I missed the last few minutes trying to goof with this iPhone headset I have and stuff like that. So I kind of lost where you guys were. But anyway, I'm Kenny. Love theology and love music and philosophy and science and all that good stuff. And was there something, Steve, that you had in mind to ask me?
Well, your ministry, I believe, is Reason for Hope. Is that what it is?
Yeah, for a while I did that. Right now, I'm just in major transition.
Are you still affiliated? Are you affiliated with Reasons to Believe?
I'm a visiting scholar there right now.
That's right. Yeah. We're going to bring you back on about 2. So let me end this real quick because I know we're running out of time. So I really want to thank everybody on the panel. I really want to thank Bill for coming back on and engaging, and especially Fuzz, who I'm not lying, is one of my favorite guests. We are going to have actually Dr. Ross on next month, the end of next month. We're going to be discussing Improbable Planet, which is his book. So hopefully you all have read it by then. I'm making progress on it. I will finish it. You know, I haven't finished it yet, but I'm reading it meticulously because I want to take notes on it. So Fuzz, if you can, please to give my best to Dr. Ross, and that we're looking forward to seeing him, and also to Anastasia, who once again does a magnificent job in arranging these things. So I want to thank everybody who's listening. I want to thank to all the members of the Great Debate community. If you're not a member of the Great Debate community, easy to do. Link is in the video description. Become one of us, join in these conversations. We open them up quite frequently. You can actually be participants and engage with very knowledgeable people like the people on the panel. Also, the links to Reason to Believe are in the video description as well as the link to Bill Ludlow's channel. So with that, thank you guys very much, and we'll be seeing you later on today when we have a discussion with Pastor Rhodes. So thank you guys.